Okay, today we're going to talk about color. And color, you guys know the colors of the rainbow. We know that color is visible light that is viewed at different frequencies. Um, we know frequencies are related to wavelength because velocity equals frequency times wavelength. And so the velocity being constant, 3.00 times 10 to the eighth meters per second, it's we generally want to think of light based on its frequency because its frequency will remain constant no matter the material it goes through. Light actually travels slower, traveling through glass or water, technically slightly slower through air than the speed of light through a vacuum. The wavelength adjusts for that speed. The frequency stays constant. And so colors are best thought of based on their frequency. The colors red, orange, yellow, green, blue, indigo, violet. The colors of the rainbow, Roy G. Biv. I'm sure you've heard that before. Color. When we see this color here as yellow, it is absorbing the non-yellow colors of light and reflecting yellow, except that's not entirely true. It reflects mostly yellow, but it also reflects some colors around yellow. And together, those colors make up our different shades of yellow. Okay, we know that there's different shades. Um, Selective reflection, it is reflecting different colors back while absorbing some of the colors, and we see the colors that are reflected or the combination of colors making what we have. So looking at this, we have a red ball seen under white light. The color is due to the ball reflecting only the red part. Not only, but mostly the red part and other colors around it, and less strength. This one, the red ball, is seen under a red light, where it appears very red, and the background around it also appears red because it's only reflecting red. When we shine it under a green light, it actually appears black because this is not reflecting any green back at us. There's no green, there's no red to reflect it back at us from this green light source. So it can only reflect colors that are in the light that's seen. The colors combine all together to be white light. Um, Light is often thought of not as um, reflected actually, but as being absorbed and re-emitted sometimes. Like what light happens when it interacts with the molecules. Let's take a look at this. Light comes in, interacts with the molecules that acts like springs. Some of it's absorbed and taken in by the springs. Some of it is bounced back or re-emitted. If you guys remember when we had the things orbiting and the electrons could jump out, they could be energized or excited when they jump out. But then when they jump back in, they emit various frequencies of light. It is often thought that certain things are kind of this process of absorbing and emitting the light, not just straight up reflecting it. So there's some potentially some of both going on here. Different materials have different natural frequencies for absorbing and emitting electromagnetic radiation. Um, and what the balance is between absorbing and re-emitting, absorbing, re-emitting, and just allowing to pass through, or like glass would, or absorbing and just reflecting off is a little bit hard to illustrate. Um, Interestingly, the petals of most flowers, such as daffodils, reflect red and green as well as yellow. Yellow daffodils reflect a broad band of frequencies. The reflected colors of most objects are not pure single frequency colors, but are composed of a spread of frequencies. That's really important to understand that there are a spread of frequencies. Um, Selective transmission. Selective transmission is going to absorb all of these other frequencies and allow one to pass through, or as it's re-emitting, you can see this single band here of blue light coming through in the sky. This is selective transmission. It's blocking out all the others, just allowing the blue to pass through. The energy from all the other ones is absorbed by this glass, heating it up. So, when red light shines on a red rose, why do the leaves become warmer than the petals? And the red light shines on a red rose. The leaves warm up because they're absorbing the red light. The petals do not because they are re-emitting. They're um, reflecting essentially that red light. So it's not absorbing any of the energy from that red light. When green light shines on a rose, why do the petals look black? When you shine green light on red petals, it doesn't have anything to reflect, so they look black. If you hold a small source of white light between you and a piece of red glass, you will see two reflections from the glass, one from the front surface and one from the back surface. What color is each reflection? White light between you and a piece of red glass. Um, the front glass, the reflection from the front surface is white because light doesn't go far beyond the red glass to allow the absorption of non-red light. Only red light reaches the back surface, so the back reflection is going to be red. Color mixing. So we're going to mix colors. Um, Colors can be thought of as red, green, blue, and there's a radiation curve to this. The radiation curve of sunlight is divided into these three regions, often called RGB, and they are the additive primary colors. Notice that as it tapers off here, our vision actually sees the middle of the spectrum the best. That's important to note. Some of you may have played some game systems that have these RGB cords, or an older, maybe DVD player might have them. And they literally sent the light to your TV as red light, blue light, and green light. When they mix together, you can make all the colors. They are called the additive primary colors. Um, these are the primary colors of light, not the primary colors of pigment. Those are different. So when you add red and blue together, you get this little color here called magenta. When you add all three of them, you get white. When you add blue and green, you get cyan, and you get red and green, you get yellow. And these are called the complementary colors of light. So yellow and magenta make white. Cyan and magenta make white. Cyan and yellow make white. So with two complementary colors, you can make any color because they're made up, each of the complementary colors is made up of two each. Um, Newton was famous for dividing this with the prism, for dividing the colors of light and seeing the rainbow, and figuring out that they all combined into white light. Newton also showed that the intensity of each one varies with the frequency from the sun, at least as far as our eyes' ability to see it. Okay, mixing colored pigments. Colored pigments do not mix the same. You mix red, green, and blue, you do not get white, you get black. Or something that looks pretty black or browny. Um, you actually have to use the what's known as the subtractive primary colors with pigment. You're going to use magenta, cyan, and yellow. And when you combine them together, you can get all the colors. That's what you would have gotten if you're doing them in art class or something. The color black ultimately is the absence of light. It's not a color, but try telling that to a paint person. The rules for mixing light and mixing pigments are radically different. Okay. White light is all the colors, um, but it's really reflecting all the colors when it's pigment. Black is generally just absorbing all the colors or an absence of light. Okay. Most things are not a pure black. They do reflect a little bit of something. Uh, some of you guys have probably seen printers that have these three colors of ink: magenta, cyan, and blue. Magenta, yeah, let me circle them. Magenta, yellow, and cyan. And those can be mixed to make all the colors, which is why, however, they can't be mixed to make black. Usually you'll also have black ink, and some of them even have like a white ink type of thing. But most printers in some form or another have these three colors and a black, whether that's a tank of ink or something. Okay, that is 27.1 through 27.5. You can also take a look at the other video on the EcoTank printer, which is just this printer that has all of these things separately.